In your chapter this week, you've been talking about pressure, and I wanted to show you one of the cool applications of being able to measure pressure at the Earth's surface. So let's look at our Earth here. So we've got a little ball, that's our Earth, and the Earth is surrounded by an atmosphere. And that atmosphere, we can measure the atmospheric pressure of the surface. So if I take out a barometer and I measure the atmospheric pressure of the surface, what I'm measuring is the weight of all the atmosphere bearing down on that point. And so you can imagine that you have a mass of atmosphere and it's experiencing acceleration due to gravity, and there's a gravitational force that's pulling it down. And as you learned in your chapter, pressure is a measure of force per unit area. And so if this force is my mass times gravity divided by the area, then if I could somehow determine the area over which this pressure of atmosphere was pushing down on, I could measure the mass of the atmosphere that's pushing down. And one way to do that is, you can, imagine how much atmosphere is above your head. You imagine there's a surface to your head there, and you've got a column of atmosphere above it, and you could go ahead and put in the surface area of your head. The acceleration due to gravity, the pressure at the atmospheric at the surface of the Earth, and you'd figure out the mass of atmosphere above your head. But you can also extend this to measure the mass of the entire Earth's atmosphere by making one measurement at the surface of the Earth. And so you can do that by noticing that the atmosphere is surrounding this entire ball, and the acceleration due to gravity is pulling in pretty much equally at all points. And so we can replace g with our acceleration due to gravity in terms of the mass of the Earth and the radius of the Earth squared. And if I put that in there, I get that the pressure is equal to the mass of the atmosphere times g m Earth over r Earth squared, all divided by the entire area of the Earth. The entire area of the Earth is just 4 pi r Earth squared. So this pressure, if we measure that on average at the surface of the Earth, is 1 bar, which is about 1 times 10 to the 5 pascals. We know that the radius of the Earth is about 6,300 kilometers. So let's say 6.3 times 10 to the 6 meters. We know that the mass of the Earth, if I look this up, is about 6.4 times 10 to the 24 kilograms. And so I know all of these things except for, and I know my G here in MKS units, so just rearranging this, I'll get the mass of the atmosphere is equal to, let's see, I put in my 4 pi r squared, so I'm going to get 4 pi r Earth to the 4th times the pressure divided by g m Earth, like that. And so just putting in those values, I'll get 4, I'll get pi, I'll get 6.3 times 10 to the 6th to the 4th power times my pressure divided by 6.67 times 10 to the minus 11, and then I multiply that by my mass of the Earth, 6.4 times 10 to the 24th. Okay, then if I look at that there, I'm going to get, let me pull this out here, I'm going to get 4 pi, I'm going to get 6.3 times to the 4th power times 10 to the 24 times 1 times 10 to the 5, divide the whole thing by 6.67 times 10 to the minus 11 times 6.4 times 10 to the 24. So those are going to go away. That'll go with one of those. That'll go roughly with one of those. And I'm going to wind up getting 4 pi times 6.3 squared times 10 to the 5th divided by 10 to the minus 11. And if you work that out, that's roughly like 5 times 10 to the 18 kilograms, which is pretty close to the actual value of the Earth's atmosphere.